Picture this. You're huddled inside your house. Right outside, there's a literal monster of a thunderstorm pushing 65,000 feet into the sky, dropping unbelievable rain and thunder. Now, normally, you'd expect to hear a warning siren, right? Well, take a look at this stark quote from a storm survivor. It is a massive reality check. The air raid sirens are no match for the deafening roar of a tornado. You can't hear a siren. They are worthless. Reading that visceral firsthand terror really hit me. It makes you realize that understanding these atmospheric beasts isn't just some abstract meteorology lesson. It's absolutely crucial. We are literally talking about life and death here. So welcome to this explainer. Today, we are digging into a pretty terrifying reality. Why Tornado Alley is shifting. The classic map of extreme weather that you and I probably grew up with, well, it's wrong now. And we really need to understand exactly why that is. Okay, let's dive into this. When I first saw this number, I literally could not believe it. 960. By May 22nd of the 2025 season alone, the U.S. saw over 960 reported tornadoes. Just to put that into perspective for you, the 15-year national average for that exact same time period, it's right around 660. So we are talking about a staggering, completely record-shattering leap in activity here. But here's the thing. It's not just the sheer volume of these storms that has scientists completely on edge. It's exactly where they're deciding to touch down. If you learned about Tornado Alley back in school, you probably picture the Great Plains, right? You think of states like Texas, Oklahoma, and Nebraska, getting hit in the spring and summer across these wide-open rural farming areas. But take a look at this comparison. The reality on the ground is shifting into what is now sometimes being called the new Dixie Alley. We're witnessing a fundamental eastward shift. The real danger zone is moving straight toward the Mississippi Valley and the southeast, places like Illinois, Kentucky, and Mississippi. And what's truly terrifying is that it's hitting during the winter and early spring, and it's targeting heavily populated areas instead of just empty fields. Now, seeing this massive geographical shift begs a pretty huge question. What actually makes the U.S. the tornado capital of the world in the first place? I mean, why is it that countries outside the U.S. see maybe 200 to 300 tornadoes a year combined, while the U.S. routinely gets hammered with over 1,200? That is 4 times as many twisters as the rest of the entire planet put together. Well, it all comes down to a very specific, almost perfect geographical recipe. It turns out, nature has a very specific meteorological recipe for this. First off, you've got this warm, super moist air constantly flowing north straight out of the Gulf of Mexico. Second, you have cold, bone-dry air dropping down from the Rocky Mountains out west. Third, high above all of that, fast-moving jet streams are blowing west to east, creating what we call wind shear. That's basically winds moving at different speeds in different directions, which causes the air to start rotating like a spinning football. Then, when an updraft pulls that spinning air vertically, boom, you get a supercell. Think of it like a figure skater pulling their arms in. As that spinning air is drawn inward toward the ground, it speeds up really fast, a process called the conservation of angular momentum. And the second that tight spinning vortex hits the dirt, you've got yourself a tornado. Now, usually we expect all of this atmospheric violence to come packaged with dark, ominous clouds and heavy, heavy rain. But nature always loves throwing a curveball, doesn't it? The concept of a clear sky tornado is genuinely chilling. This is an exceptionally rare phenomenon where the storm system's rotation actually separates completely from the visible rain and precipitation. So a funnel literally descends right beneath blue skies. No rain, no dark clouds, absolutely zero visual warnings. It's a terrifying reminder that these atmospheric dynamics don't always look like some big Hollywood disaster movie until it's way too late. So, how do we actually track these invisible atmospheric monsters? Now, what's really interesting about this slide is how it shows exactly what meteorologists are looking at. Looking at the scan from the National Severe Storms Lab, the left side shows reflectivity, so that's your typical heavy rain and hail. But check out the velocity map on the right side. Those bright reds and blues, they indicate winds moving incredibly fast toward and away from the radar. When those colors pinch really tightly together, forecasters know for sure there is intense rotational velocity. They are literally watching the storm relative flow and mesocyclone formation happen in real time, long before any human eye could ever spot a funnel through the rain. Okay, so what is actually pushing all of this eastward? The data points to a few major culprits behind those record-breaking 299 tornadoes we saw just in March of 2025 alone. First up, we had a weak La Niña climate pattern, which creates a much wavier, much stormier jet stream. You combine that with abnormally warm waters in the Gulf of Mexico, which basically acts like high-octane fuel pumping tons of moisture further inland.
Interestingly enough, the data shows that overall tornado days in the US are actually decreasing slightly. But when they do happen, they are these explosive, highly concentrated outbreak events, and they're happening further east than ever before. But look, this isn't just some fun trivia fact for weather nerds about map coordinates changing. This eastward shift has incredibly serious consequences. It means these storms are entering deadlier new territory. If we trace the history of these massive, era-defining outbreaks, a really disturbing trend starts to emerge. We go all the way from the infamous 1925 tri-state tornado, which traveled over 200 miles and killed 695 people in the Midwest, to the terrifying 2011 Alabama super outbreak that completely devastated the Southeast, right up to today, where March 2025 shattered the monthly record with 299 tornadoes. The big takeaway here is that the long-track, catastrophic outbreaks of the past are quickly becoming our modern, everyday clusters. So what makes this new normal so incredibly dangerous? Well, it's a perfect storm, pun intended, of factors unique to the Southeast. First, these storms are striking heavily in the winter months, like December and January, when people just aren't expecting them at all. Second, there's a much higher frequency of nocturnal tornadoes. Just imagine a violent tornado hitting after 11 p.m. while your entire family is fast asleep, just like we saw recently in London, Kentucky. Now, combine all of that with a higher population density, a serious lack of traditional underground storm shelters because of the local soil types, and this hilly, heavily forested topography. All those trees and hills make it almost impossible for storm spotters to visually see a tornado coming. It just drastically reduces your survival odds. But it's not all doom and gloom. Scientists are fighting back hard with some absolutely unprecedented technology. What you're seeing here is data from the new Advanced Technology Demonstrator, or ATD radar. Unlike the older systems that take literal minutes just to scan the sky, the ATD provides incredibly fast volumetric updates. It can actually capture two supercells merging together in real time and spot the exact moment an early EF0 tornado genesis begins. It can even track hail as it's falling out of the sky. It's an absolute game changer, giving meteorologists a massive advantage when trying to track these fast-moving nighttime storms. And this brilliantly illustrates an incredible leap in technology when you look at the overall timeline of storm hunting. Back in the 1990s, the deployment of Doppler radar totally revolutionized detection. Then, by the 2010s, dual polarization upgrades let forecasters literally detect flying debris in the air, meaning they could confirm a tornado was on the ground even in pitch blackness. After that came the livestream era, starting around 2015, where storm chasers and drones started providing instant visual ground truth. And today, we're actually using AI models like GraphCast, working alongside traditional supercomputers to augment forecasting and predict exactly where these outbreaks will happen with jaw-dropping accuracy. Yet for all this incredible data and supercomputing power, we really have to remember the human element behind all of this. During these super outbreaks, local meteorologists are often on the air for hours straight, basically playing a game of atmospheric roulette to save lives. You can truly hear the heavy burden this places on them in the words of meteorologist James Spann, talking about the 2011 outbreak. He said, "We didn't save 252 in my state that day. I won't accept that, and I'm very driven to find out what went wrong. Let's get in there and fix it." The drive to improve those warning lead times is a relentless, incredibly heavy burden borne by the scientific community. The stark truth we all have to face today is that Tornado Alley is now essentially everything east of the Rocky Mountains. The old borders have completely vanished. And just like forecasters say about hurricanes, we now have to say the exact same thing about tornadoes. It only takes one single storm to change a community forever. So as this geographical footprint of extreme weather continues to shift and expand right into our backyards, is your hometown prepared for the new normal? Thank you so much for joining me for this explainer today. Stay safe out there and always keep looking up.